Part 2 starts from here. Now solving the right hand side. So on the right hand side we have cosecant A plus cot A the whole square. So now here the first step is to convert it into sine and cos form. So I can write this cosecant A as 1 upon sine A, and I can write cot A as cos A upon sine A. This is whole square. Now the second step is to take the LCM. Here we have a common LCM, that is sine A, and in the numerator we have 1 plus cos A whole square. Now I'm going to rewrite this expression as 1 plus cos A whole square and the denominator as sine square A. So what I'm going to do here, I'm going to write this 1 plus cos A whole square as 1 plus cos A into 1 plus cos A. Again, why I am not applying the formula of A plus B whole square? Because on the left hand side I don't need A square plus 2AB plus B square. There is no 2AB on the left hand side, so there is no need to open the bracket using the formula of A plus B whole square. And as far as the denominator is concerned, you can see here this is sine square A, so we can use the first identity to find the value of sine square A. So here sine square theta plus cos square theta is equal to 1. So I can write that sine square theta is equal to 1 minus cos square theta. So I can write this sine square A as 1 minus cos square A. Now again I just need 1 plus cos A upon 1 minus cos A on the left hand side. So I'm going to rewrite this expression. The numerator will remain same, that is 1 plus cos A into 1 plus cos A. I'm going to rewrite the denominator in the form as A square minus B square. 1 square is 1, and cos square A can be written as cos A whole square. So basically this is A square minus B square, and the formula of A square minus B square is A plus B into A minus B. So I'm going to write the denominator in this form, A plus B into A minus B. So here the numerator will be 1 plus cos A into 1 plus cos A, and the denominator can be written as A plus B into A minus B. Clearly we can cancel 1 plus cos A and 1 from the numerator and the denominator, and we are left with 1 plus cos A upon 1 minus cos A, which is our left hand side. So left hand side is equal to right hand side, hence proved. Again, we are solving the right hand side keeping the left hand side in mind. So please don't forget that, otherwise it will become difficult for you to solve these identities. Next question. We have to prove that cot A plus tan B upon cot B plus tan A is equal to cot A into tan B. Oh, it's a little bit confusing like that, but nothing to worry about. We're gonna solve this. So here again I will be solving the left hand side and applying the first step to convert it into sine and cos form. I can write cot A as cos A upon sine A and tan B as sine B upon cos B. So same thing applies to the denominator. Cot B can be written as cos B upon sine B, and tan A can be written as sine A upon cos A. Now the second step is that taking the LCM. So first of all, in the numerator, LCM will be sine A into cos B. So if we compare this LCM and the denominator of the first term, we are left with cos B. So we will get cos A into cos B in the numerator, and with the second term we are left with sine B into sine A. We are going to apply the same method of taking the LCM in the denominator. So the denominator LCM will be sine B into cos A, and taking the LCM, we will get cos B into cos A plus sin A into sin B. Now we will be taking the reciprocal of the denominator. So what expression we get, I'm going to write it down. The numerator will remain same, and taking the reciprocal of the denominator, we will get sin B into cos A on the numerator, and in the denominator we are left with cos B into cos A plus sin A into sin B. So now if you compare here, the numerator of the first term is cos A into cos B plus sin B into sin A, and the denominator is also same, cos B into cos A plus sin A into sin B. So this will get cancelled with this one, and we are left with sin B into cos A upon sin A into cos B. I am rewriting it as sin B upon this cos B into cos A upon sin A. And as we know that sin theta upon cos theta is tan theta, so we will get tan B here, and cos theta upon sin theta is cot theta, so we will get cot A here. So this is what we get on the left hand side, and this is what we have on the right hand side. So the left hand side is equal to right hand side, hence proved. Now the next question, we need to prove cos A into cot A upon 1 minus sin A is equal to 1 plus cosecant A. Again, I would be solving the left hand side. So following the first step, I would first of all convert it into basic, that is sine and cos form. This cos A is already there. I can write it down cot A as cos A upon sine A. And in the denominator, again it is in the sine form, so we need not to do anything. So now I'm going to multiply cos A with cos A, so I will get here cos square A, and in the denominator we have sine A, and here we have 1 minus sine A, and if I take the denominator of this, we have 1 here, and if I take the reciprocal, it will be cos square A upon sine A into 1 minus sine A. And if you want to just do the shortcut, you can always keep that in mind, that the denominator of the numerator goes to the denominator of the fraction. I repeat, the denominator of the numerator goes to the denominator of the whole fraction. Or if you don't understand, you can take the reciprocal. So now we will get the expression as cos square A in the numerator, and in the denominator we have sine A into 1 minus sine A. Now it's time to look at the right hand side what we want. We just want 1 plus cosecant A, and cosecant A is equal to 1 upon sine A. That means there is no requirement for the cos square A. So we can substitute the value of cos square A using the first identity, that is sine square theta plus cos square theta is equal to 1. So here it is sine square theta plus cos square theta is equals to 1, and I can write the value of cos square theta as 1 minus sine square theta. So I'm going to substitute the value of cos square theta as 1 minus sine square A, and in the denominator we are left with sine A into 1 minus sine A. Now I'm going to rewrite this numerator as 1 square minus sine A whole square, and the denominator will remain same. So if we look at it, this is A square and this will be B square, and A square minus B square is equals to A plus B into A minus B. So I'm going to rewrite this numerator into A minus B form. So here I will get A plus B into A minus B. And in the denominator, we are left with sine A into 1 minus sine A. So this and this will get cancelled out, and we are left with 1 plus sine A upon sine A. Now, on separating the denominator, I will rewrite it as 1 upon sine A plus sine A upon sine A. So this will get cancelled and it will give me the value of 1, and 1 plus sine A can be written as cosecant A, and this will be plus 1. So if you see here, we got cosecant A plus 1, which is equivalent to 1 plus cosecant A of the right hand side. So the left hand side is equal to right hand side, hence proved. Thank you very much for watching this video. For more videos, you can visit our website transalearning.com. Have a great day.